Plastic is such a double-edged sword, right? Because it's so convenient. It's made things a lot easier. It's pretty much impossible to avoid.
Welcome to Dog Cancer Answers, where we help you help your dog with cancer.
Hello. I'm Molly Jacobson. I'm the editor-in-chief at dogcancer.com, where we cover all things dog cancer. And today I have an interview for you with Dr. Charlotte Hacker. She is a geneticist, and she did a huge in-depth article on plastics for us because plastics cause several known carcinogens. Honestly, it's a little terrifying, and I'm going to make a disclaimer now. I laugh and I smile a lot, especially when I get nervous. And honestly, this topic terrifies me. So you're going to see me laughing. You're going to see me smiling. That does not mean that I think this is funny. It's not funny, but I kind of tend to laugh at the absurdity of life. So hopefully that doesn't bother you and you'll forgive me if I seem to be making light of a very important subject. Now let's go to my previous conversation with Dr. Charlotte Hacker. Dr. Charlotte Hacker is with us today to talk about the article that she wrote for dogcancer.com about plastics as a known carcinogen cancer cause. And Charlotte's asked me to call her Charlotte. She's a wildlife biologist, and we'll talk a little bit more about your background in a minute. But first, I just want to welcome you to Dog Cancer Answers and thank you for all of the work you've been doing on behalf of dogs with cancer and the people who love them.
Yeah, of course. Thank you for having me. This is a job I'm really passionate about doing and excited I get to be on the podcast now as well.
Yeah, it's really great to talk to you because you have such a clear-minded view of science for many, many reasons and so much great experience in animals and wildlife and genetics, cancer. Mm-hmm. And so you wrote this really interesting article about plastics that frankly terrified me. You know, we asked you to write it and then I read it and I thought, oh my goodness, I'm so glad we switched all of our plastic things to glass a couple of years ago. I feel so much better about my health already just after reading that. So my first question is, should we panic about how much plastic is in our lives?
Plastic is such a double-edged sword, right? Because it's so convenient. It's made things a lot easier, and it's pretty much impossible to avoid nowadays. You know, but then we're hearing on the other hand, it's evil, it's bad, you know, you need to cut it out of your life. And what's really scary about plastic is just some of the chemicals that are involved. And it's better than it used to be. There's not as many scary things or not as much of scary things that go into plastic, but it's still definitely something to be mindful of. And with all the alternatives, you know, it can be pretty simple to switch some of these things out and try to minimize your plastic use in general, not just for the environment, but for your own health.
Right. So let's talk about that. Let's talk about some of the chemicals that are commonly found in plastics and why we're concerned about them. And then let's talk a little bit about plastic itself, why it as a carrier of these chemicals can be concerning. I'll ask you a better question. Let's talk a little bit about those chemicals that are in plastics that we should be concerned about, that scientists like you are concerned about.
So one of the top ones that you've probably heard about is bisphenol A, BPA for short. That's kind of the one that gets talked about the most because it was once really, really prevalent in plastics and still is to a certain degree. It's responsible for making plastic hard and clear. So you can imagine how many things it's been used in. When we think of plastic, we usually think of the clear, hard plastic. But unfortunately with BPA, it's known to interfere with the normal functioning of your hormones. So this is a chemical that's called an endocrine disruptor. And, you know, you have the endocrine system in your body. Your dog has an endocrine system as well. And that endocrine system is responsible for kind of pumping out and reading and producing hormones. And you can think of hormones I like to think of them as kind of little messengers that are constantly running throughout the body. And they're basically telling your body what it needs to do and when. So every molecule, every cell in your body has a job. And hormones are responsible in some capacity in almost every function of those. And so when you have a chemical like BPA introduced into the body, and the body thinks that it's a hormone because BPA in and of itself is mimicking a hormone and ultimately affect biological functions, it can affect things like proper development. It can have large-scale effects with even small doses. And it's in, it's pretty much in everything, it seems like.
What is it commonly found in, BPA?
So a lot of it, polycarbonate plastic, as well as epoxy resin. But it's in things like the lining of food cans. So like your dog's food, or the food that you eat, vegetables that might be in a can. A lot of cans will say made without BPA lining or something like that. And that's great, right? You as a consumer might think, good, I'm going to take that off the shelf. I'm going to buy that one over this other brand. But what you might not notice at first is there's usually this little asterisk right next to, no BPA in the lining. And that asterisk actually on the back will tell you that there's no BPA intentionally added. So as per regulations in the United States, you can intentionally add a lot of these chemicals that are in plastics. But they still show up, they still happen, they can still be a part of that process and still be detected. And so even if you think you're buying something that is BPA free, you still want to be mindful that it might not actually be 100% BPA free.
I'm glad to know what that asterisk means. We didn't put any BPA in here.
Yeah, basically.
But we didn't necessarily remove any BPA that was already present.
Sure, yeah. That's essentially what it's saying. Yeah, and it's in very small, tiny print. It's hard to miss unless you're kind of looking for it. And I think we as consumers are just wanting to make these easy switches. And so we buy into that, right? We buy into that label and then are kind of misled a bit.
So the BPA was originally used and is maybe not taken out now because it basically puts a little plastic lining over the metal of the can, and that would mean that the metal of the can doesn't eventually over time sort of dissolve and start to give you that metallic taste that you can get in plenty of food. I remember that taste very well from my childhood. So it sounds like there's a good intention behind plastic's use in this case, but the consequences, do you think they knew? Do you think they knew that this was an endocrine disruptor when they first started using BPA?
I'm not really sure. But what we have seen in general is a lot of diseases associated with the endocrine system that have spiked, and that spike has coincided with the use of plastics being more and more ubiquitous kind of in our daily lives.
Like what kind of diseases? I know there are several cancers that are driven by endocrine system cancers or are sensitive to hormonal changes in the body. So I imagine that's one category of disease. And what else?
Yeah, any, like you just said, breast cancer, all sorts of cancers of endocrine functioning organs, but a lot of developmental issues. So, hormones are playing a big role during development. They're kind of in overdrive in a lot of ways. And development's really this critical time period for things to kind of get up and running. You can almost think of it as like, your body's going through all of these changes, and especially in utero.
So that sounds like a lot of problems that we've seen. Yeah, a lot of spikes in developmental issues in children.
Yeah, and a lot of weird things like allergies. Allergies have been linked to having some of these chemicals or exposure to some of these chemicals, which is, something people can live with. But other times allergies are very severe and life-threatening. And so it kind of runs a wide spectrum of possible outcomes.
Crazy. Okay. So more than one reason to try to eliminate BPAs. What's another chemical? Yeah. What's another chemical that we are concerned about in plastics?
There's a broad group of chemicals that are commonly known as plasticizers. And they're things like phthalates is a big group, and alkylphenols are a big group. And they're essentially chemicals that make plastic easier to work with. It's found in a lot of things. Personal care products like shampoos even have them, which is kind of, bizarre to think about. And
why do you need plastic in your shampoo?
I know, it's kind of scary, right? It's like, why? Why do we need that?
Yeah.
But at some point along the manufacturing process, that gets in there.
Did you say fluorine?
Flooring. Like not like
flooring?
Like flooring, like on the floor, like construction
Like
material,
on the
that
floor.
kind of thing. Yeah. Yeah.
Oh, like
So it's
all
in
of
your
the
house.
laminates
Yes.
that's in your house.
Yeah. And there are several types of phthalates, for example, that are considered restricted substances under the United States Consumer Products Safety Improvement Act. It's a mouthful. And others are considered substances of high concern in countries like Japan and in the European Union. And so we know for sure that they're also considered endocrine disruptors, just like BPA is, and that they are, ones that we want to be worried about.
Yeah, I imagine that this ingredient, the phthalates, I'm not saying it right. I imagine this ingredient that creates like a plasticizing effect would make like a personal care product feel nice. I can imagine that in a shampoo, I guess, maybe it would give some slip, or it would make it feel more luxurious under your fingers. Or if I saw that on a label and I knew that meant plastic.
Yeah, that would definitely, I'd rather have less luxurious feeling and safer shampoo, I think.
The point is clean hair.
Yes, exactly. Lead is sometimes added to plastic.
Lead?
It's definitely, yes. It's definitely not as common as it used to be, but it has not been banned necessarily altogether. We know that they are dangerous to lead exposure.
That's so disappointing.
And yeah. I mean, lead is a tough one because it was historically used in so many things. And, we know what the outcomes can be of exposure to lead, especially for children.
That's just astonishing to me that we would be using lead for almost anything at this point, given what we know about it.
Yeah. And thankfully, it's not as much as it used to be, but just any of it is alarming.
What other chemicals are we worried about in plastics?
Alkylphenols are another one. And they're very similar to phthalates in terms of their function. They're used to make plastics more moldable, thinner. They're one of these, so-called plasticizers. But they undergo a wide range of chemical reactions. In fact, some of them are, certain alkylphenols cannot be used in the EU because of the products that they ultimately make during these chemical reactions. That's another one where we know that the ultimate result is, we're essentially making an endocrine disruptor during the commercial process of using alkylphenols. And so as those change, the alkylphenols become, something else, and that ends up being an endocrine disruptor.
Yeah, this happens a lot. We think about ingredients, but we don't think about how things change when we process those ingredients. This happens in food, right? With acrylamides being produced in the cooking process. So they're not in the food. The food becomes saturated with them or coated with them, depending on what kind of food you're making and how you're cooking it.
So there are some chemicals that are used in plastic, or some plastics that, for example, PVC is a well-known one, polyvinyl chloride. It's in your plumbing system, it can be on the siding of your house. It is everywhere, right? PVC in and of itself, even though it's a plastic, is not a known carcinogen. The problem with PVC is that often BPA has to be added to it to make it moldable. So there's that aspect of it. But what's really, kind of more of an issue in my view is that there's a chemical that is released, vinyl chloride, or, a gas that comes out of this during the manufacturing process of PVC. And vinyl chloride is a known carcinogen. The manufacturing process of making this plastic ends up releasing this known carcinogen that is really, really, a known endocrine disruptor, has a lot of environmental outcomes. We're seeing it right now, and we're seeing the environmental fallout from something like that. And so you're still being exposed to something that is an endocrine disruptor in the process of that plastic getting from, point A to point B and being made.
Right. There's consequences to every decision we make, isn't there?
Yeah. And it's exhausting sometimes, right?
It really is. It's really, I understand why people don't pay attention to this stuff, because it's overwhelming when you start to really look at it, because I'm imagining a world without PVC and I can't.
Yeah, it's one of those things that because plastics are so ubiquitous and pretty much unavoidable, even if you buy something that's not plastic, it probably came in plastic packaging, right? You know, so there is kind of this element of helplessness and hopelessness in terms of, you know, dealing with these things.
Briefly, let's go over the history of plastic that you found, because I thought this was fascinating. I'm really glad you included it in your article. And to me, it speaks to the hope that the humans have for the future. Yeah. And we're always trying to solve problems. And sometimes we create problems and we try to solve them. And I guess we just like solving problems because we're always creating more to solve.
Exactly. Yeah, it seems like that. You just roll from one to another. But you're right. I mean, plastic over the last 2 centuries has had this really interesting history. Kind of the ancestors to plastic had been made prior to the mid-1800s. Inventors had experimented with different chemicals and had made a product that was plastic-like. But really the drive to come up with something that could be mass-produced came from manufacturing industries that used ivory, and specifically elephant ivory. You can get ivory from other animals, but typically we focus on elephants. And during that time period, elephants were certainly taking the brunt of that. And so during that time, you know, manufacturers were like, ivory is getting way too expensive. We can't afford it because we're running out of elephants. We're decimating these elephants. And so they put out a call to inventors in the mid-1800s, and they said, if you can find us something that functions and looks like elephant ivory that we can use for, you know, ivory at that time was used for so many things, jewelry and trinkets and chess pieces and billiard balls for pool tables. And, you know, it wasn't this infinite resource. And there was a species that was suffering because of that. And so this inventor kind of answered that call. And he ended up experimenting with hardened nitrocellulose. And with that, he had kind of, you know, he patented it. He called it celluloid and patented it under that name. And what was so special about his product was that, you know, it could be produced in mass. And even then, celluloid had a bit of a problem because it relied on boiling down the bark of the camphor tree. So that was one of the ingredients that had to go into it. The camphor tree is, you know, it's a species that we have in the United States. It's in states like Florida. But, you know, even though we had moved away from elephant ivory, we still were relying on Mother Nature for a resource in terms of this camphor tree bark. And so that made that product ultimately limited by a source that humans couldn't, you know, really control. But then in 1907, another inventor came along, and he was the one that finally designed, you know, the first synthetic plastic that didn't rely on any kind of natural outside resources. And so that really catapulted the possibilities of what could be done with plastic. And so that's kind of, you know, the actual story of it getting started seems like, okay, well, that's good because we reduced pressure on these, you know, wild populations of animals, species, trees. But now, you know, by the 1960s, we were finding plastic in the ocean.
Right. So let's talk about what it does to the environment and why. Plastic basically breaks down over time. Mm-hmm. All plastics do. Am I right about that? That's my understanding.
Yeah. I mean, any chemical can theoretically break down. Like chemicals are held together by these bonds, and those bonds can break. And so bonds can break due to all sorts of things. You know, you can think of temperature, you know, and things like that are what make plastic kind of dangerous, right? Because those chemicals have to go somewhere.
I'm just thinking about a way. I like to come up with a metaphor because I'm not a scientist. I'm a writer. So I'm thinking about like the mortar between bricks.
Yes.
Let's say that you have a brick wall and there's mortar. Mm-hmm. So the mortar would be like the chemical bonds, and the bricks are the chemicals. So if that mortar degrades over time, you'll have those bricks just fall out of the wall. And it happens, right?
Yeah, or the chemicals will release from each other. I mean, they're kind of holding each other together too. So you can think of, yeah, that's a really good analogy. I mean, the brick kind of being the plastic itself, right? And plastic is composed of these chemicals. And as these bricks kind of fall out, now they're in the environment.
Right.
And as that brick wall gets fewer and fewer bricks, eventually the whole wall is going to come down.
You've got all of these bricks that are unfortunately carcinogens, and they're not being held safely together in a solid thing that you can use, but instead so if I pick up something plastic and it's old, and sometimes plastic gets that like a little powder on it almost, or here in the tropics, because I live in Hawaii, we get things break down quite quickly. Like even supply lines that we use for plumbing. I've never had to replace a supply line in my life in the Northeast, but here every 5 years we have to replace them because they are breaking down and they'll spring a leak really easily. That actually makes me think our water supply is being contaminated over time. I'm not just going to replace them because they spring a leak. I think I'll replace them because they're releasing plastic chemicals into my water. Oh my goodness.
I know, this stuff is scary.
It is scary. Yeah. So don't use plastics, I would imagine, when they seem old. Like that would be it's not just about it's no good anymore. It doesn't look good anymore, but might actually be dangerous.
Yeah. It's a good idea to replace your plastics for sure, and if you can't switch to an alternative,
right.
If you're going to bother with replacing your plastics, it's probably best to just switch to something like glass or, I've switched out all my Tupperware containers the last couple of years to, glass ones. And so, yeah, older plastic is definitely not going to, it's going to be leaching things for sure. And if you're heating up your food in it or, keeping food in general in it, right? That's probably best to replace that altogether if you can, but definitely get something new if you have to use plastic.
And the heating and the freezing cycle of those plastic containers like Tupperware and others, we don't have to use a brand name, plastic food containers. So when plastic food containers are, you put your food in them, you put them in the freezer, or you take them out of the freezer, you let them thaw, and then you put them in the microwave to heat it up. That's not good because that extreme of temperature is, of course, going to weaken those chemical bonds as well, right?
Exactly. Mm-hmm.
So best not to keep food in plastic in general.
If you can avoid it, yeah.
Oh my goodness. So what does this do to what do these endocrine disruptors do when they're released into the environment?
They can affect wildlife. There's a lot of really interesting research right now on the way that these endocrine disruptors are impacting species like fish and changing the sex of fish in certain waterways and really altering the development of species. A lot of these species, that live in these fragile environments are very specifically adapted to those specific environments. And so introducing something new into it or flooding it with something like endocrine disruptors, that wildlife, they're going to absorb those chemicals. And then, they're kind of stuck with the consequences of that. And that can lead to some really weird population dynamic outcomes, like being heavily skewed towards one sex or the other. And ultimately, those chemicals those animals are ingesting are going to have similar outcomes as they would in us over time. And that's still something that we're trying to understand, especially when it comes to something like cancer. What is the direct link between plastics and those chemicals, endocrine disruptors, and the risk and development of cancer? But it wouldn't be that far-fetched, I would think, that we would start to see something like a cancer or a disease.
What do we know about dogs specifically and cancer risk when it comes to plastics as a carcinogen?
So tricky with cancer because there's never just one cause. It's so multifactorial and things that you're not even, your dog's genetics, you can't change that. And so there are really things that are underlying that are, you're kind of trying to control what you can. And endocrine disruptors can certainly play a role, especially with the endocrine-related cancers. So like mammary cancer in dogs. We see like kind of an uptick in that. There was a study on tumor growth on the prostate in dogs, and exposure to plastic increased the growth of those tumors on the prostate. And so we know that there's, a perceivable link between the use of plastics, or at least exposure to those endocrine disruptors, and possible cancer disease outcomes with dogs. But actually picking that apart is really tough to do, to be able to pinpoint, exactly what the underlying causes are. And a lot of that too is because we just need more time. These things aren't necessarily working overnight to cause these big mass changes. And so you could have a study that, would take decades to actually be able to pinpoint these effects. And, we know that dogs unfortunately don't live that long.
Right.
But we definitely know that they're impacting their bodies similar to the way that they impact ours. And dogs are usually pretty good models when looking at diseases and kind of transferring knowledge from humans to dogs and vice versa. And so, we know it's affecting us. It's definitely affecting dogs as well.
Yeah, that is a problem with cancer. So often we want to know, like, how do I prevent this? What do I do? And the answer too often is we don't really know exactly how to untangle all of these factors. We just know that we need to reduce as many factors as we can. It's really not simple, and it never is.
And that's what makes, I think, cancer so frustrating, right? And like, you never quite, like you said, you want to do as much as you can to reduce risk. And I think that's really the goal to keep in mind, is you might not be able to eliminate the risk, but you can certainly do things to reduce it.
Let's talk a little bit about your background as a wildlife expert and what your day job is. I want to hear a little bit about you.
So I wear many hats, I feel like, these days. My research and my work is kind of more so at the intersection of wildlife ecology, biology, and international relations and policy. And so my work most recently has been helping to shape international policies that work towards, protecting the environment and protecting species. And so that's kind of my day job right now. But I came from a very heavily field biologist based background. I did conservation genetics for my PhD. So that's essentially, you can kind of think of it as like crime scene investigation with wildlife. We use a lot of the same techniques.
I love it.
So my job was basically to walk around the mountains and pick up animal poop. And animal poop contains DNA. So you extract the DNA and you can get all sorts of information. You treat it kind of like a piece of evidence at a crime scene. We're using the same kind of molecular techniques to get that DNA and to figure out, what species deposited the scat. We can get individual profiles to see who's moving around in the area. We can even look at the DNA of what that particular animal ate to get an idea of diet.
Wow.
And I did this in very high altitude environments. So there's some degree of molecular mechanisms that allow species to live in these environments where there's not as much oxygen.
Okay.
And I became interested in that, trying to understand what does that look like genetically. So I focused on snow leopards for that, and just kind of interested.
Beautiful animals.
It was, I say that casually. I've been very fortunate with the things I've gotten to do in my career. And a lot of those same pathways and those genes that are involved in hypoxia adaptation are involved in tumorigenesis and cancer.
Aha.
And that kind of opened the floodgates for me in terms of my interest in, and just in general, the molecular mechanisms genetically that may lead to cancer or be something that puts a particular species, organism, individual at risk for certain types of cancer. And so that's kind of where that component of the work that I do for you guys comes in. And then, all of that started with my childhood dog, right? Like, she's the reason I love animals and wildlife, and everything kind of stems from her. So tracing it all the way back, it started with, my pet German Shepherd, and now I'm here.
What was her name?
Her name was Gladys.
Oh, yeah. Gladys, the German Shepherd.
Gladys, the German Shepherd. My dad brought her home one day.
Did you name her?
No, my dad did.
What an amazing name.
Yeah. I came off the bus one day and he had a puppy. And that was probably one of
Oh.
my like first core memories as a kid. I was, I think, in kindergarten, first grade, maybe. So yeah, oh, Gladys.
That must have been a really, really good day in your life.
Oh my gosh, like definitely top. I still, when people ask me, I think that still comes to mind. I've had many good days, been very lucky, but that one definitely comes to mind.
That's so sweet, Charlotte. That's one of the things that I love about the work we're doing is that everybody involved has a dog who, a dog's love in their heart that inspires their work. And it's so satisfying. If your dad were giving you Gladys today, what kind of toys would you get her? And what kinds of what would you get for your dog, knowing what you know now about plastics?
Yeah. Well, I do have a miniature dachshund now.
That's right. Of course you do.
But she's not much of a toy. She's more of like a bone kind of chewer. I would avoid plastics as much as possible. I would focus on things like rope toys, more natural substrates and things like that. Especially if, Gladys was a chewer. She would chew toys up. And you're breaking those bonds as your dog, your dog is chewing.
Literally.
And they're breaking the bonds and, swallowing pieces by accident, whatever it is. And it's really unfortunate because the dog toy industry is not nearly as highly regulated as something like the kids' toy industry. And, with dog toys, really the only rule is that you can't intentionally add harmful substances. And that list of harmful substances is, much shorter than what we would see in children's items. You can try to swap out for kids' toys. Sometimes those overlap enough. So if you are looking to get your dog something plastic, squeaky, whatever, it might be worth looking into something that's meant for a kid. And some pet companies are ahead of the curve and they are already, not using those chemicals. And you can certainly seek those companies out. They're going to be more expensive toys, but in the long run, way better for your dog.
And they're probably talking about that in their marketing. They're probably saying we manufactured a kids regulations and or they're talking about all of these chemicals of concern and saying they don't have them in their products, or they're using exclusively like hemp to make their toys so that for sure that is not a plastic. So I imagine plastic bowls, like you would want to use a glass or stainless steel.
Anything that your dog, with their food or water touches should not be plastic. If you can help it. There are, like you said, tons of alternatives: glass, stainless steel, ceramic, depending on how old it is. There are some dangerous chemicals in older ceramic glazes. So to be mindful of that, but that's a different, topic. But yeah, you could definitely switch out, or even, I think of the big plastic containers that some people keep their dog food in. So instead of having it in the bag, they'll put it in big plastic containers. If you can switch that out for like metal or something like that, that's, a really kind of easy thing to do. Don't keep it in the bag necessarily, because the bag is probably lined with plastic. So,
that's true.
It's always something, right?
Decant your dog food.
Decant your dog food.
Oh, is there any other thing we can do on a practical level to reduce our dog's exposure to plastics? I'm thinking about laminate flooring all of a sudden and how dogs are closer to the floor than we are. They're basically in bare feet and they lick it.
If you have the option to, if you're renovating your house or something and you want to be mindful of what is being used in the construction of your house, that is possible. Those are kind of bigger scale things that may not be practical for everybody. But if you can, put a rug down, if you can do something that helps reduce their exposure to plastic, that's probably, better than nothing. But if they're not chewing it, it's probably not too terrible for them. If you have a dog that's like, if you have them in a crate, for example, if you crate train your dog and they have the little plastic floors in the bottom, if your dog is a chewer and chews that, you need to find an alternative, or you should try to find an alternative. Okay. But if your dog is just laying in it and it's got its blanket and it's just chilling, it's just hanging out, you're probably okay. Your dog's probably not getting that kind of more troublesome exposure in terms of the risk of ingesting those chemicals in the plastic.
That makes sense. That makes a lot of sense. So I'm kind of back where we started, which is we should be concerned, but try not to panic, because we can't live in a plastic-free bubble in the modern day.
Yeah. Yeah. You're absolutely right.
Is there anything else that listeners can do on a practical level other than reducing their own exposure or their dog's exposure? Are there any other action that if somebody who, like, should they write their senator? Should they call Congress? Like, is there any important legislation going on or anything that they should specifically ask for?
Yeah. I mean, it seems like things are constantly changing or being, in the process of being updated. And you can literally vote, and you can vote with your wallet, right? You can choose to buy certain products.
Right.
You can send a message that way.
We are in a capitalist society.
Yeah. And where you put your money, they will eventually listen. That can be intimidating. I hear people say often, well, I'm just one person, and, how is my one choice going to make a difference? And it's like, okay, well, how many people are listening to this podcast and now going to check labels for BPA, right? It infiltrates. It does eventually kind of get out there and can make a difference. And so try to, keep that in mind when you feel like you're just one little consumer. You're part of a massive, very, very effective, group of people that can kind of incite these movements for change. And what seems to me the most difficult in terms of crafting new legislation, and what holds it up a lot, is this disparity on how much is too much. What are the actual toxic levels? So, for example, the amount of BPA that can be in something, or the amount of BPA that a human can be exposed to within a lifetime that is considered safe, is way higher than what it is in the EU. And the EU just recently reduced that level and dropped it, by thousands of percent. So it's, even if you have legislation that's going through and being pushed through, that's great. It's usually for the better, not always, but that kind of depends on politics and all sorts of other things and where the money is going and coming from. But you still want to keep in mind that just because it's regulated to a certain level doesn't mean that we really have a good handle on that level being safe. And that's part of the scientific process. We're constantly adding in new information and updating things. And, sometimes we're wrong. But even new legislation is, take it with a grain of salt sometimes in terms of what is being put out there.
Before we started recording, we had a little conversation where we were talking about healthcare and how in a country where healthcare is paid for by the taxpayers via the government, where there's a universal healthcare, for lack of a better word, that government is incentivized differently than it is in a system like ours. In a system like ours, the government is not incentivized to prevent sickness as much because it doesn't have to pay for the treatments. So it's possible, in my layperson's mind, I'm not a politician, I'm not a scientist, but it's possible that we are looking at lower levels in the EU and countries like Japan, because those are countries where they take care of the healthcare costs associated with having citizens. And they are directly responsible for the health of their citizens. And so they do more to prevent illness there than we do here in the States. And I just think that might be something for everybody to think about a little bit, that maybe if we, whatever your thinking is about universal health care, perhaps we should be thinking about it as a way to incentivize all of these policies a little bit differently, because a lot of things fall out from that when you're looking at cutting costs in healthcare, because you have to pay for it. Prevention becomes much more important.
Yes. Yeah, that's a really good point.
So maybe indirectly, that's something people could do.
like I said earlier, you might feel like you're not moving the needle at all, but you as an individual have, a lot more power and a lot more influence, I think, than we give ourselves credit for.
I think so.
And we've seen changes happen in the past, so it's possible.
It is. And lobbying from the public does matter to politicians. Mm-hmm. It doesn't matter in all cases, but it does matter if they pay attention when they get phone calls.
Yes. Yeah. Yeah.
Well, I just so appreciate you coming on the show and doing all of this work and writing the great article and being your science-y self. And thank you so much, Charlotte,
no, thanks for
joining us
this
today.
Was fun. It was good to chat.
So good to chat. And I'm sure that we will have more to talk about later.
Yes.
But thanks for joining us today. Thanks so much for watching this important show. Check the show notes for links to Dr. Hacker's article and other resources that will really help you protect yourself and your dog. And don't forget, reduce plastic as much as you can in your environment. I'll see you on dogcancer.com, where we cover all things dog cancer, so you have better information today, so you have no regrets tomorrow. Make sure you like, comment, and subscribe so you see our next episode. I'll see you soon.
Thank you for listening to Dog Cancer Answers. If you'd like to connect, please visit our website at dogcancer.com or call our listener line at 808-868-3200. And here's a friendly reminder that you probably already know. This podcast is provided for informational and educational purposes only. It's not meant to take the place of the advice you receive from your dog's veterinarian. Only veterinarians who examine your dog can give you veterinary advice or diagnose your dog's medical condition. Your reliance on the information you hear on this podcast is solely at your own risk. If your dog has a specific health problem, contact your veterinarian. Also, please keep in mind that veterinary information can change rapidly. Therefore, some information may be out of date. Dog Cancer Answers is a presentation of Maui Media in association with Dog Podcast Network.